All right. So I was talking about electronegativity and how to determine that. So I was talking about carbon and Se, and I said, carbon's 2.5, Se's 2.4, 0.1 nonpolar covalent. And the point that I was making is that you can't have a negative score. So if you were doing like SEC, SE is 2.4, C is 2.5, and you get negative 0.1, take the absolute value, right? Turn that negative 0.1 into positive 0.1. Just take the absolute value of that number. So polar covalent is scores between 0.4 and 1.9. So let's say that you had carbon and silicon. Carbon's 2.5, silicon is 1.8. Subtract the two, and that's 0.7. What a polar covalent bond is that you have an unequal sharing of the electrons. One atom has a greater share of the electrons, and that is the atom that is more electronegative. The way we usually show that is an arrow with a plus sign at the tail. So the plus sign says this atom is more positive, and the arrowhead says this atom is more negative. And so if your score is between 0.4 and 1.9, you are still covalent, but you're in a polar bond, an unequal sharing. Then if you're larger than 2, you are an ionic bond. So if you look at any of the metals and nonmetals, so like sodium and chlorine, their scores, so sodium and chlorine, sodium is 0.9, chlorine is 3.0. That's a score of 2.1. That's an ionic bond. That's an uneven sharing of these electrons. All right, so let's see if we can use this information. So I'll do A, and then I'll let you do B, C, D, and E. So what I want you to do for these is just tell me if the bond would be pure covalent, polar, or ionic. And if it's polar, tell me what direction the electrons flow. So first one is carbon and nitrogen. Carbon has a score of 2.5. Nitrogen has a score of 3.0. So the difference between carbon and nitrogen is 0.5. So this is polar covalent, because between 0.4 and 1.9 is polar, and the electrons are flowing towards nitrogen. So flow towards nitrogen because nitrogen is more electronegative. Now I do have a poll for you to answer so I can see how everyone's doing. So, or I should, there it is. So tell me for the remaining B, C, D, and E, what type of bond they are. And if it's polar, tell me which way the electrons are flowing. do about 30 more seconds for this. So make sure you get your answers in. Well, the chart given to us not only the differences, but include not only the differences, but the bond types. Probably not. I will not say like 0 to 0.4 is covalent and 0.4 to 1.9 is nonpolar. No, I'll just give you the numbers if you need them. That's it. All right, so let's take a look at this. So BR. So BR is 2.8. BR is 2.8. Subtract those two, that's 0. So that's covalent, nonpolar. Carbon and chlorine. Carbon is 2.5. Chlorine is 3.0. So that's 0.5. That's polar with our electrons heading towards the chlorine because that's more electronegative. Carbon is 2.5. Sulfur is 2.5. So that is nonpolar covalent. SR is 1.0. Chlorine is 3.0. So the difference between that is 2. So that's ionic. So yep, just look at this chart, be able to read it, be able to use it. Any questions about that? So all O's are polar covalent. So all O's are non-polar covalent. I'm not sure I understand. All zeros. Yeah, all zeros are non-polar covalent. So pure covalent means non-polar. That it's the same thing. All right. So our last thing for a couple minutes is that we are just going to work on Lewis structures. That's all I have left for you. So see if you can't draw all these Lewis structures. I will actually do B for, well, I'm going to do A and B for us because they have things we haven't seen before. So let me do those really quick. So we have C2H2. So carbon, hydrogen, hydrogen. All right. So remember, hydrogen only binds to one thing only, and carbon are going to be in the center. So it's going to look something like that. So hydrogen has 1, carbon has 4, carbon has 4, hydrogen has 1. So let's keep our tally. So we have carbon, carbon, hydrogen, hydrogen, 4, 4, 1, 1. All right, so make a single bond there. Hydrogen has 2, carbon has 5. So good. So make another bond. Hydrogen has 2, this carbon has 5. That hydrogen's good. Right. Single bond between the carbons. Now they have 6. Uh-oh. A single bond didn't do it. My carbons are at 6. Whatever shall I do? Well, you can make up to a triple bond. So you can do this 2 more times. So I'm going to make another single bond between my carbons here. That carbon goes to 7. That goes to 7. Oh, wait, they're not at 8 yet. Okay, let's make a triple bond. Goes to 8, goes to 8. So this molecule has the Lewis structure of that. So if you find yourself in a position where you don't have enough electrons, then you can use a double bond or a triple bond. And actually, I guess I'm just going to do B as well, and then we'll call it. And then on Friday, I'll give you time to practice these. So B, let me do this. Oxygen has 6. Hydrogen has 1. Here's the first time we've ever had a negative charge when doing this. So if you're a negative charge, you get to add an extra electron. That's what the negative charge means. I get exactly 1 electron. If it was -2, I would get 2 electrons. So let's do this. Oxygen, 2, 3, 4, 5, 6. Hydrogen gets 1. And then we have a floating electron. So oxygen has 6. Hydrogen has 1. So I'm going to make a bond here. 2, 7. So right now, oxygen's at 7. Hydrogen's at 2. So hydrogen's good. Oxygen, though, wants to be at 8. And we cannot make another bond to hydrogen. Hydrogen can only have a single bond. However, we have not placed all of our electrons yet. So if I count on the left, I have 6 electrons from oxygen, 1 electron from hydrogen, 1 electron from my negative charge. So I have a total of 8 electrons to place. Hydrogen, I placed 1 electron so far, and I put my 6 electrons around oxygen. I've only placed 7 electrons. So I get to place 1 more electron. And so I'm going to put it right here. So now oxygen has a full octet. And I place all my 8 electrons. So from A and B, what I want you to get is it's okay to do double bonds and triple bonds. You're going to need to do that at some point. Never to hydrogen, though. And if you have negative charges, you get an extra electron. So is there any questions or any clarifications how I did A or B there? I know I did that a little bit fast. If not, I'll let you do C, D, E, F, G. I'll give you class time to do that on Friday morning. So no need, don't feel like you need to do C, D, E, and F, G on your own time. We will dedicate some class time to that. Otherwise, I'll put up a homework this homework will be due on Sunday at midnight because it's directly relevant to the test. How many questions are there in the upcoming exam? No idea. I've not written it. Will we have class on Wednesday? No. Even though it's technically not a holiday, I'm not planning to have a session then. Because usually, even though COVID is a thing, usually Wednesday is historically a traveling day. So I'll just allow that to be a study for the final exam day. So nope, I'm not having a session on Wednesday, and I'll make an announcement about that. Otherwise, if you do have questions about going over the tests, please let me know. And I will see people later. Have a good one, everybody.